with M&Ms, but it might be fun to see about other kinds of candies or different liquids other than just water. So far we used room temperature water for a long time, and then we did try 2 temperatures. Additionally, we added the cold, and then we added the hot temperature. But there's lots of things out there we could try. We could try different liquids and different kinds of candies. So let's just brainstorm ideas. I don't have everything, but I do have some stuff hidden in my cupboards for you guys. So.
For candy, you can use Jolly Ranchers.
Okay, Jolly Ranchers. Okay, what else? Just give ideas. We'll see what we have.
Skittles.
Skittles.
We have those.
Yes.
For liquids.
Oh, liquids. Okay.
Soap and concentrated water.
Ooh, and what kind of concentrate?
Salt.
Okay, salt water. Cool. Okay, so salt water and we'll say dish soap. Is that what you mean?
Mm-hmm.
When you say soap? Okay. I guess we'll take liquids or candy at this time then.
Right.
Okay, a pop. I'm going to just say pop because I do have a pop and I don't have 10 kinds of pop. So we'll just say pop, okay? So that's a good one. Okay. Sabrina?
Licorice?
Oh, for candy. Okay, yeah. Yes.
Starburst?
Yes.
Orange juice?
OJ. I'll just say juice. Again, if I have these things, I don't have like big varieties of them. So, what else?
Jelly beans?
Oh, jelly beans. Cool. Yes.
I don't know what they're called, but they have like the mint inside and the chocolate on the outside.
Oh. What? Junior mints? Is that what you mean, or do you mean?
Yeah,
Okay, so they're all the brown
Yeah.
with the white inside. Yeah.
Lifesavers.
Okay. Yes, Trey.
Reese's.
Yeah, Reese's Pieces. Haley?
Sour Patches?
Oh, yeah. Evan?
Pop Rocks?
Oh, yeah, cool. Oh, we're gonna eat one, huh? Ashley?
Sweet Tarts?
Okay. All right, how about a few more different liquids we could, or no, sweet tarts you said, right?
Yep.
Other liquids?
You vitamin water?
Oh, yeah. Yes.
Gatorade?
Okay. Colton?
Isaiah gave me the idea.
Okay. Did you say milk?
Yeah.
Yeah? Is that your idea too at that table? You guys are all thinking alike over there. Another idea?
Syrup.
Syrup. Okay. Think about this. What about some other kitchen type things or things you might find in your pantry?
Vinegar.
Yeah.
Olive oil?
Olive oil. Okay, let's just take a few more and then we better get planning. Hannah.
Popcorn butter? Like, you can get like this little...
Okay, so popcorn butter. Yes, start.
Kool-Aid.
Kool-Aid. Okay, I think I'll stop you. Because the truth is, you just get what I have in my cabinet anyway, so. And you've covered quite a few things. So I want to ask, so what do you guys think is different? Like if we look at let's say Jolly Ranchers and Lifesavers compared to Skittles and Reese's Pieces. What would be different about those kinds of experiments if you were testing and comparing those kinds of candy? Taylor?
Well, with the Skittles and Reese's, the Skittles might end up kind of being like the M&Ms.
In what way?
Well, because of like they kind of still have the hard shell and
Okay.
then kind of like a softer
Good.
inside.
That's exactly what I was thinking. With Jolly Ranchers and Lifesavers, there's no candy shell. It's the same on the outside all the way down to the last little bit of it, right? But with Skittles, Reese's Pieces, the M&Ms that we've been working with, they all have a candy shell. So we are going to focus on candies that have a shell because that's what we've been studying so much to see how they dissolve and the rate of dissolving in water and different temperatures of water. So I will tell you what I have. I do have Skittles, I do have Reese's Pieces, and none of these other ones had the candy shell. I have one other one. I have mini robin eggs. So like little, these things. So they'll have like yellow, blue, pink, white, speckled shells. They are good. So I have those 3 candies, and I still have M&Ms if you'd like to use M&Ms for part of your experiment for what you're testing, okay? For the liquids, well, I have salt, so we could do salt water. I have dish soap. I have pop. It's like the Twist Up Sprite stuff. I don't have juice or vitamin water or Gatorade. I have milk. I have corn syrup. I have vinegar. I have regular oil. I have Kool-Aid. Let me just check my laboratory over here. So I have heavy whipping cream is one that I did not mention. Why do you guys think I would have cream and then a 1% milk? I saw your hand right away.
Because the fat might not make the color go out as much.
Okay. So which one?
The whipping cream.
Okay, so whipping cream, he said it, he was right on the button. It has a much higher fat content, so we would see possibly different behaviors or dissolving rates with cream compared to milk. So I have whipping cream, milk, oil, pop, I have Kool-Aid, I have vinegar, I have all the things mentioned and some other chemicals that we've used actually in the past too. So, okay, so what we need to talk about before we can go ahead and plan our experiment with our team is what kinds of variables could we test or should we focus on controlling when we do these experiments? So what's one thing?
The amount of candy.
Okay, good. So you and your, that's very good. And I'll just say the amount of candy so you and your team will decide, you know, are we going to put 1 piece or are we going to have 2 or 3 or that's one thing that you should consider is the amount and it should be the same. So that's good.
Would you put your candy in liquid in? Like
Oh.
if you put it on a plate?
Okay, perfect. So our container, plate or cup. Okay. Sabrina?
Maybe colors.
Okay, so like if you're going to compare colors or same color, different liquid, whatever you're, because it depends on what your group will plan, so that's very good. So the color of candy. So in some cases you would want it to be all the same, or maybe that's what you want to test is the different colors. So you and your group decide that. Ashley?
The amount of like liquid that you want to put.
Very good. Volume of liquid. Good. What else?
Maybe the temperature of it.
Okay, so for like, just so you guys know, most of my things are room temperature, although these were in the fridge this morning. So these 2 are a little bit cold, but everything else is room temperature, just so you're aware of that. But that's good to consider too. Other ideas? Yes.
What if we put the candy in a chemical reaction?
Okay, so
Like vinegar and baking soda? If we put the candy in there, what would happen?
what do you think would happen?
I have no idea.
You know, I think that would be a good experiment, but the only thing is what we've been talking about more is the rate of dissolving of these candies, so let's stick to that today, and that is something we could do another time. I'm sure it would be interesting.
Alright.
Okay, Taylor.
For like the salt water, the amount of salt we put in.
Okay, so amount of salt or Kool-Aid powder, those things, that's good to consider. What's another name for things like that if it's the solid in your solution? You guys remember? You're saying it. I'm going to see Evan, your hand. What does it can change the concentration, the amount that you add. What did you say over here, Taylor? Yeah, solute. Good job. Okay. Anything else you can think of to make this a good experiment? What have we talked about with, or what do you remember from the M&M experiment?
Where you place them?
Awesome. So placement. And one thing we talked about, like in my other classes, it's like we talked about putting the M&Ms maybe about 2 centimeters apart. We would read that, we would discuss it, and I think we get excited when we have it. And not everyone would do that. Some people had them like way far apart on the plate or touching. So one thing I think that would be helpful, and I just put out for you guys, is you can mark the plates or cups with a permanent marker. So that's, if you remember, what would be a good place to put it then? Regina?
The time.
Oh yeah, that's another, you're right. So I'm going to add time and placement. But what about where to place it? What do you guys think would be good?
Like,
Yeah, in the middle, I think, because it's just an easy spot to eyeball with the marker, right, on the plate or the cup. So go ahead and mark them. So those are the two I was looking for, though, is placement of candy and time. And then you and your group can decide on the time, so I'll just leave that up to you. You can stick to the 1 minute we've been doing with our other ones, or you can change the time if you'd like to also. So we have the amount of candy, plate or cup, so the container, the color of the candy, volume of the liquid, the temperature, amount of solute, basically if you're making some of those solutions, where you place the candy and the time. Do you have another one?
Yeah.
What?
I was just saying if you want to put it flat or on the side.
Oh, good. So how you place the candy too, right?
Yep.
Okay, so you guys, these are a list of variables that you and your team or your group could test. So what's the most important thing to remember when you decide what to test? Like, what do you have to do with the rest of the variables? Do you guys know?
Leave them the same.
Yeah, you have to control the other variables and only change the one thing at a time. Otherwise, you really don't have an experiment because you have too many things that you change and then you don't know what your outcome is. So what I would like you to do then, you guys, is on the Science in Action page, come up with your question for part 2. Talk about your variables here for part 3. And then just maybe make a short prediction on what you think will happen. Like, what do you think the outcome might be when you do your experiment? So, and then once you're ready, just go ahead and raise your hand real quickly and I'll look it over and then you can get started. Okay? Any more questions? Okay, start planning.
We should do Skittles. What kind of candy does she have? Skittles. Anything that's startup. Oh, Reese's Pieces.
Skittles.
There was M&M's, but it could have been cool if we did use the Robin eggs, because like we could see what was inside Robin
Because there's like chocolate it's like M&M's.
Well, I think that you can have 3 different candies if that's your
Okay, next let's do that. Okay, so we'll do Robin eggs and vinegar. Next, select your question to investigate. Based on your question on something you investigated with M&Ms and water, write what you plan to investigate in the question. Will the vinegar dissolve?
Everyone takes a vote.
We have to do it. Me and
Yes, we all do the same thing.
Okay, so we said pop, dish soap, vinegar, and then the whip, like the heavy whipping. Yeah. Try and vote again. Okay. Who votes for pop? Pop. Vinegar. You guys are you guys willing to do it? Are you willing to do anything else besides pop?
Well, if we do 2 kinds of candies, we can also do 2 kinds of liquids.
I think we can only do one kind and then
I think like
she said we could compare them, like the milk and the other one earlier.
but a lot of kids they did like
Okay, who votes for pop? Vinegar. Ooh, he raises his hand. Okay. We're gonna have to let something go. Okay, rock, paper, scissors. Let's go. Come on. Or we could let a piece of candy go and have 2 different ones. Okay, what candy? We should let the what go? Reese's. Yeah, I don't really like Reese's. Now we'll do pop and vinegar. Okay. So, you just, okay, you want to write pop or like right here then? Yeah. So we're doing pop and okay, so now number 2. Next, select your question to investigate. Base your question on something you investigated with M&M's and water. What size? 7. Write what you plan to investigate in question form. So does how about do pop and vinegar make candies? Okay, then water. Do pop and would you say like help her make it?
Okay, so pop, vinegar, and salt, right?
Make candy, Skittles and Robin eggs. Okay. Robin eggs. Dissolve faster? Yeah. Dissolve faster or slower? Faster or slower. So we should have, oh wait, then water. Faster or slower than water. So, we'll just pop and vinegar make Skittles and Robin eggs dissolve faster or slower than water. Than water. And then how will we set our experiment up? I think we should, you know how we did the M&Ms in the plates? Maybe we could like try them, maybe in the whole sprint. Let's try it in the cup and let's just pick one. Okay, raise your hand if you want the cup. Raise your hand if you want the plate. Okay, so, and then how long are we gonna like observe it? Let's do 2 minutes. Okay, so 2 minutes, and we'll use the plates and how much water, or like vinegar and 50. Okay, so we will use the plates. And use 50 milliliters of our solutions, liquids. Well, they are solutions. Yeah, 50 milliliters of water. And then we will observe for 2 minutes. Is that right? We will have the experiment for 2 minutes. We have our experiment for 2 minutes. Do you guys have any predictions?
What do you think it'll do? Even write an arrow. Like, what do you think will happen in the pop? What do you think would happen with vinegar? Do you think they'll all have a reaction or no?
No, I just think the ones that pop in vinegar and then the soup will just
You think it will? Okay. So then just write down what you think for each one. You guys can start once you have everything.
pop, soap, and vinegar in a cup.
Together.
Okay, everybody all together.
I think candy.
Like, you poured it exactly right on the egg. It's like pour it over on the side.
There. Yeah. Who's doing blue?
Try not to pour it exactly like right
Don't try not to put it in. Yeah. Whoa. Don't waste it all. Oh, that's cool. That's good. Okay, use the rest of that. Who's doing white? Just push it around.
Nobody likes white.
I'll do white.
Oh yeah, it's other greenish.
Okay.
We might have to do some.
We might
Oh, I'm
need
doing
yellow.
dye.
I'll do half of yellow.
Okay.
See the blue dye coming out.
Careful. It's good.
I don't know. Alright.
Just dump this in there.
Yeah.
We're dying.
We need a little more.
Oh, look, you can see the blue coming out.
Yeah. Look at what's around it. That's cool.
I don't see it. But I see something on the face.
Well, it's acid.
Didn't make any. It's
Alright, let's
How many colors are there?
the white, the shell is colored. Nobody has. That one has all the red because
No, it doesn't. Not all of it. The bottom has. Well, the bottom has this the color on it. Yeah, but it's also going to affect it because vinegar is an acid. So. But the shells already came off that one, and that one, and that one, and that one.
The only thing almost the same.
Well, you can see the white. So.
Little stuff candy.
Yeah.
So just do enough to like cover it. Or the plate.
Like red and green.
If that's what you guys want to do, that's fine.
Alright.
That would work good.
Alright, here we go.
Well, this is all the stuff we talked about, just like the what color of the candy, plate or cup. Yeah, the things that are already.
I wrote that up here. Are you
Then that's fine. And then just make it.
okay? I'll just put mine No, they're using it for every cup.
We need more vinegar.
No, we're fine. Okay. I think we need a little more dish salt.
There. That's enough. Okay.
Too much.
Yeah, I remember they phoned each other.
Doesn't matter.
What is it? What are they doing?
I don't even know.
They're like, what are they doing? They're bubbling? Like, is it from the Twisted or is it from the Skittles?
It's from the Twister.
Well, it's letting off the red stuff. It's letting off the gases.
Hold on.
There goes the purple.
The red's already doing it too.
The brown is kind of making a purple.
Ready? I think
It's brown.
Yeah.
You can smell the twist because like it's making a gas. It's making a gas and it's coming up. You can smell it. Vinegar. No, this.
You can smell the twist.
Do you see like the explosions on it? Yeah, it's just I think that's the S right there.
Whoa, that one's turning on.
And this one's turning red.
That was not the middle.
I guess it's not really staying up.
Stop, don't move it. Don't move it.
There's like a small portion that's purple.
Because it's like the paint.
The only thing that it's really doing is exploding. To me, it looks like there's gases coming out of the Skittles, but it's really only the twist.
It's like a fizz.
What are you guys finding?
Katie, put your head away. What is happening is like from the twist pop, all the like the I don't know how you say it, the suds are like they're going onto the Skittles and now they're like making a reaction.
It looks like it's eating away at it very quickly.
Yeah.
So are you comparing the colors to you guys? Or just...
We did, but it looks like in the cup. I don't know if
It's like one of them takes most over most of it.
barely even went too. Our orange is really turning the color.
And what do you notice? Remember when we did the M&Ms in water? How it, even when it was covered like this in the cup, the color would not spread? Is that the same with pop then?
It looks like the color in the orange one over there went on the top.
Yeah, it looks like red here.
It does look
It
like
looks
that.
like the orange went red over the purple.
It does look like it. So that's why do you guys think in water? Because a large part of pop is water. What else is in pop? Sugar, carbonation.
There goes the S.
So do you think that that's affecting why our color is spreading? Or what do you think? The carbonation, the gases in it from oxide. So why do you? Huh?
It's all white.
No, it's all eaten away at. Do you think that's why it's spreading, or do you think it's a different reason?
I think it's like what they covered it with. Because now it's not fizzing at all once all this stuff's covered. Once all
I see fizzing, or what do you
I still see fizzy.
just don't see the color? Maybe is it less?
It takes the color
Well, what I'm
and
wondering,
to the top, takes it to the top, and spreads it.
well, what I'm wondering is if it'll keep fizzing until the Skittle is practically all gone. Because to me, the Skittles, like what the inside is. The inside to me seems like sour. Plus, this is probably sour, so I'm thinking it's gonna keep going and going until the Skittles are gone.
Well, that will be something we can leave it and see what happens.
Yeah.
Actually.
No!
Very cool. Write down whatever you guys predicted and the next page.
Oh, okay.
One that's just
What are you finding here? What are you finding here?
Well, this one came out, the color came out way faster than all of these. Then this one you can't really see it, it's just on the bottom. Well, yeah, like it's not coming off as well.
It's just all white. It's getting white. So the coating is kind of.
Yeah, but it's slower than the M&M.
It's slow, but it's coming off.
Red is, see? Red is the red.
Have you seen the orange? It has a big piece
That one, that one, that one.
This one's last.
Let's see how dynamic Greg is.
What are you finding here?
We're finding like which one dissolves with the most color first. Like how fast it goes. We did like 2 minutes.
What did you use?
Vinegar and Skittles. So far, what are answers?
Oh, prediction. We didn't make prediction.
Just say like it will.
How it will. Why?
Because vinegar is a little It's a soft vinegar. Watch me stir. So you
What are you guys finding?
We're doing Robin eggs and Skittles with room temperature water, twist up pop, and vinegar. And so far, we're doing it for 2 minutes, and it's kind of like. I can't really try anything yet. Ready yet. So far, it's pretty
And what did you guys find here? On which experiment?
We did two. We did robin egg and vinegar and Reese's Pieces with robin soap.
What happened? On the Reese's and the soap, the yellow dissolved faster because you can see that there's like yellow particles in it compared to the. Oh, never mind. Well, they're pretty easy to dissolve in soap. So. Orange is like, yeah. They're pretty easy to dissolve in soap.
I think because the soap is washing off.
Yeah. And then in the robin eggs, the vinegar took the coat like right off.
This is white, and the water is yellow.
This is pink and the water's kind of peach. So. Vinegar. This is green. And a blue. You can see the blue dye now. You see it? Now what are you finding?
Well, we found out that like the color goes like it kind of like goes around the edge on parts of it, and it looks like lighter right here, but then when it goes out, it looks darker. It's funny.
We found out that the Skittle, the coating of it dissolves and spreads out more than the robin eggs coating.
Yeah, really.
Yes.
A lot. This one's just more darker than the
What did you guys discover?
This one had the biggest effect.
What is it?
We used pop, and we had a yellow Reese's piece, and you kind of see it's like turning the water yellow. And in this one, nothing really happened. And then in the vinegar, it's kind of turning yellow.
It is turning yellow because you see white. It's yellow. Vinegar smells gross.
They all smell really good.